Welcome back to the class. Yesterday we have started the acceleration analysis of the mechanisms and the formula we have derived yesterday for the acceleration relation between the 2 points of a rigid body. The formula that we have in hand now is for any 2 points P and Q of a rigid body, while we treat this to be our x-axis and we consider this to be our y-axis, and let's suppose we have a rigid body. This rigid body is undergoing planar motion. We locate 2 points of the rigid body, point P and point Q, and draw a vector between P and Q. Okay. Then what we derived yesterday was acceleration of point Q. We had the formula. Acceleration of point Q is equal to acceleration of point P. Acceleration of point Q is equal to acceleration of point Q plus angular acceleration of the line or the vector joining P and Q. That was alpha, angular acceleration, alpha vector, and its cross product with the radius vector from P to Q. That was RPQ vector, and minus square of angular velocity, that is theta dot square, or magnitude of angular velocity, which you write as omega square RPQ vector. This is the acceleration formula we have derived yesterday. Now let's try to apply this formula on the given mechanisms. Let's take this problem for example. We are given the rod AB as shown in the figure. We have a rod AB in the figure is confined to move along the inclined planes A and B. There are 2 inclined planes. This is inclined plane A and this is inclined plane B. This rod is constrained. This rod AB is constrained to move along the plane, along 2 planes, inclined planes A and B. If A has an acceleration of 3 meters per second square, point A moves down with an acceleration of 3 meters per second square and a velocity of 2 meters per second, and the velocity of point A is 2 meters per second. Both directed down the plane at the instant the rod is horizontal. Okay, the directions are given to us. This VA acts in this direction and AA is also given. The direction of velocity of point A and acceleration of point A is given. Determine the angular acceleration of the rod at this instant. Now we have to say how much is the angular acceleration of this rod. That is, we have to find the value of alpha. Okay, we have to find the value of alpha for this rod. Okay, now how we do, since we have lots of ways of doing this question, we can also use the what you call as the analysis. The velocity analysis can also be used, but since we will be using the acceleration analysis to solve this problem. The problem is easy. It's not that tough a problem. Okay, so what we will be doing, let's apply the acceleration formula. First we have to locate 2 points, point A and point B. Okay, since we are given the acceleration of point A and we are not given acceleration of velocity of point B, so point B is quite unknown to us. So what we do, let's draw a vector. Let's first draw the vector, location of 2 points, draw the vector from point A to point B. So this is our vector from point A to point B. Okay, like in this problem, in the derivation, we had the vector from P to Q, we wrote that as RPQ. We have vector from A to B, we write this as RAB. Okay, now select any point as your origin. Okay, you need not to write the origin as well. Let me directly show it. Now we can write, we know the velocity of A, acceleration of A, we don't know the velocity and acceleration of A. Okay, so we can directly write the acceleration formula, that we can write acceleration of point B, acceleration of point B is equal to acceleration of point A is equal to acceleration of point A plus angular acceleration of the rod AB, like we has angular acceleration of the vector PQ. Here will be angular acceleration of the rod or angular acceleration of the vector AB. So we write this as, this is alpha AB. This is alpha AB vector cross, we have to take its cross with RPQ. So here it will be RAB vector minus omega square. Omega is the angular velocity of AB. So it will be omega square RAB vector. Omega square RAB vector. Okay, this is the formula that we have yesterday derived. Okay, so now as far as the acceleration of B is concerned, we have no idea about the acceleration of B, except the fact that what we are given here, if point A has an acceleration of 3 meter per second square and velocity is 2 meter per second square, we are given acceleration and velocity of point A, both directed down the plane at the instant the rod is horizontal. Okay, so you see, you look at the how the rod is moving. As the point A moves downwards, as the point A moves down, the point B will move up. Okay, as is given here. Okay, so it means as far as the velocity and acceleration of point B is concerned, since point B initially was here, now point B is here. After some instant of time, the point B will be here. Okay, so as far as the velocity and acceleration is concerned, you can say that the velocity of point B is directed along this. This is the direction of velocity and acceleration of point B. The way you have here, the velocity and acceleration here is directed like this. In the same way, the velocity and acceleration here will be directed like this. Okay, so that the point B moves along the inclined plane. If it's directed not parallel, if this velocity and acceleration is not directed parallel, then it will not move on this horizontal plane. It will move out of the horizontal plane, which is not actually the case for us. So as far as we say, the acceleration of B will be directed here. It will be parallel. So we know as far as the angles given to us are, the angles that are given to us are, if we just reduce it forward, then essentially we are in better position right now to say that as far as the acceleration of, as far as this angle is concerned, since this angle and this angle, they are corresponding angles, this will also be 45 degree. So acceleration of B, which is in this direction, can be resolved into two components. We can write its component will, along this x-axis, we'll write this as, this will be AB cos of 45. This is AB cos of 45. This is directed along x-axis, and this component, its component along y-axis, it will have a component acceleration, will have a component along y-axis, and that will be equal, that we can write as, this will be AB sine of 45. That is acceleration of B and sine of 45 degree. Okay, so we can write this as that. As far as AB is concerned, we can write this as magnitude AB cos 45 I cap, AB cos 45 I cap plus AB sine of 45 j cap. Okay, AB sine of 45 j cap. Acceleration of B will be directed here parallel to the plane. It will have two components, will be equal to. Now look at the acceleration of A. Acceleration of A here is given to us as, acceleration of A is equal to, acceleration of A is 3 meter per second square. You can resolve this acceleration. You can write this as, this acceleration can be resolved into two components. One component will be along this direction, and its another component will be along this direction. Okay, the component of acceleration along this direction, since this angle and this angle, they are vertically opposite angles, this will also be 45. Component of acceleration along x-axis will be 3 cos 45 I cap. So we'll write this as, this component of acceleration is 3 cos of 45 I cap. This is, and its component along y-axis is negative y-axis component, that is minus 3 sine 45 minus 3 sine 45 degree j cap. These are its components. Okay, then we have this is acceleration of A we have written. Then we have alpha AB. We don't know the angular acceleration of AB. Okay, angular acceleration is not known to us, except the fact that as far as the rod is concerned, look how the rod is moving. Initially the rod is horizontal. After some instant of time, this point goes down, this point moves up. Okay, so if you look, the angle that is now described with respect to the x-axis, initially it was horizontal to the x-axis, but after some instant of time, if you draw the vector, initially if we draw the vector AB, the vector AB initially was, the vector AB initially was like this, okay? This was vector AB. Now, after some instant of time, this point B will come down and point B will go up, point A will go down, point B will go up, and the vector AB will be now in this direction. The vector AB will be now in this direction. This will be the direction of vector AB. If you look, the sense of rotation of this rod, the angle that is being described, initially it was horizontal, now it's like this. The angle that is described is in this direction. The angle is being described in anti-clockwise direction, or we say the rod is rotating in anti-clockwise direction. Okay. Now, if we curl our fingers, in the direction of this anti-clockwise direction, the thumb will come along z-axis. Okay, so as far as the angular velocity or angular acceleration is concerned, for the rod AB, the angular acceleration will be directed along the z-axis. So we'll write it will be alpha. This is the magnitude of angular acceleration, and it is directed along z-axis. So we'll write this as alpha k cap. It is directed along z-axis because the sense of rotation of the rod is anti-clockwise. Okay, and we have to take this cross product with AB. As far as the AB is concerned, AB vector is concerned, at the instant that is given to us, AB vector can be written as far as this vector AB is, now vector AB is, its magnitude is 10 meter and it's along x-axis. So we'll write this as, this is 10 I cap. Okay, this is vector AB for us. Minus omega square, we don't know the angular velocity magnitude. So this is omega square. We'll write this as omega square itself. Okay. We'll write this as omega square, and RAB vector is 10 I cap. Okay, so this is our acceleration equation. Let's write this as equation 1. We'll call this as, this is our equation number 1. Remember this equation. Now, in this equation, the unknowns that we have unknowns. We have to find the value of acceleration of B. That's important. We have to find the value of alpha. Okay, but we have the value of omega. So we need to find the value of omega. As we know from velocity analysis, in previous questions, when we were given the velocity of point B, A, we could find the velocity of point B as well as we could find the angular velocity of point B with the help of velocity analysis. Now, write down the velocity equation between point B and point A. When we write the velocity equation between point B and point A, we can write directly our velocity of point B, because we are drawing vector from A to B. It will be velocity of point B is equal to velocity of point A plus angular velocity of the rod AB, that is omega AB, angular velocity of the rod AB. Okay, angular velocity of the rod AB cross radius vector RAB, that is RAB. This is the velocity formula for us. Okay, velocity relation formula. Now, velocity of point B, again, if you look at the point B is, initially it is here, after some instant of time it's here, after some instant of time it's here. So velocity has to be parallel to the plane. Okay, for this roller to roll over this inclined plane, that is, we can directly say that velocity of B will be directed along this direction. Now again, this VB can be resolved into two components. This will be VB cos 45 and this will be VB sin 45. So we can write this as, this is VB cos 45 I cap, this is VB cos 45 I cap, and its J component will be VB sin of 45, VB sin of 45, VB sin of 45 J cap is equal to velocity of A. The velocity of A, we know velocity of A is directed in this direction. It can be resolved into two components. This will be VA cos 45 I cap, and its another component will be downwards. That will be VA sin 45 minus J cap. So it will be VA, that is 2 meter per second. That is 2 cos 45 I cap minus 2 sin 45 minus 2 sin 45 j cap, minus 2 sin 45 j cap. This is the velocity of point A. Plus angular velocity, we don't know, except the fact that as far as angular velocity is concerned, since the rod AB is rotating in anti-clockwise direction, if we curl our fingers if we put our fingers in the direction of anti-clockwise, the thumb will come along z-axis. So we'll write this as omega k cap cross, its cross product with RAB. RAB is 10 and it's I cap, 10 I cap. Okay. So this is VB by under root 2. VB cos 45 is VB by under root 2 I cap. We'll write this as VB by under root 2 I cap plus VB by under root 2 J cap. VB by under root 2 J cap is equal to 2 by, it's 2 by under root 2 I cap. It's 2 by under root 2 I cap minus 2 by under root 2 J cap. So we'll write this as 2 by under root 2 J cap. Then do we have omega cross 10, that is 10 omega. Then we have K cross I. We know this is I, this is J, this is K. As far as K cross I is concerned, K cross I is equal to J. Sense is cyclic, therefore it will be plus J. So it is 10 omega J cap. Okay. Now we balance the I and J components on right and left hand side. So the I and J components on left hand side we have. First we balance these I components. When we balance these I components, so we have I component and this is the I component. We have rest of the components are J components. So we can write VB by under root 2 when we balance the I components. VB by under root 2 comes equal to 2 by under root 2. Okay, because this and this are the only I components we have. Under root 2 cancels. As far as the value of VB comes equal to, the value of VB is equal to 2 meter per second. This comes out, we say the value of VB, I'll write here, the value of VB is equal to 2 meter per second. Okay, so this is the value of our VB. Now balancing the J components, we have VB by under root 2 on the left hand side. VB by under root 2 on the left hand side will be equal to, on the right hand side we have J components. J components on right hand side is minus 2 by under root 2, minus 2 by under root 2 plus 10 omega. Okay, plus 2 under root 2 10 omega. Okay, and VB is equal, which is equal to 2. Okay, VB is equal to 2, so it is 2 by under root 2. So we have minus 2 by under root 2 plus 10 omega is equal to 2 by under root 2. So if we take this 2 by under root 2 here, so we will have 4 by under root 2. So 10 omega is equal to 2 by under root 2 plus 2 by under root 2 is 4 by under root 2. So our omega will come out equal to, omega will be equal to 4 divided by 10 under root 2 radian per second. Okay, so this is the value of omega, radian per second. So let's perform the calculation and see how much is 4 divided by 10 under root 2. So let me do these calculations. So I have 4 divided by 10 divided by under root 2. That is 0.282. Okay. So this value comes out equal to 0.282. So as far as the value of omega is concerned, the value of omega is 0.282. This is 0.2828. So we can write this as 0.283 radian per second. Okay, so 0.283 radian per second is the value of our omega. Now in this equation, we will, in the acceleration equation, we will put the value of omega. Okay, so now we can write, let's rub this analysis we have performed. Let's substitute the value of omega in the previous equation. So as we go ahead in performing it, we will have the value of, it comes out, we can therefore write this as, this is AB acceleration equation by cos 45 is under root 2. So it's AB by under root 2 I cap plus AB sine 45 is under root 2. So that is AB by under root 2 J cap is equal to 3 by under root 2. This is 3 by under root 2 I cap minus 3 by under root 2 J cap. Now we have alpha into 10, that is 10 alpha. Okay, that is 10 alpha. And we have K cross I. See, K cross I is equal to J. So it's plus K cross I is equal to J. We'll write this as 10 alpha J cap. Then we have minus omega square. As far as omega is concerned, our omega is 0.283. So this is 0.283 square into 10 I cap. Okay. So now what we will do, we will assemble all the I components together. So the I components on the right hand side we have 3 by under root 2 is what first I component we have, that is this I component, and we have this I component, that is minus 10 into 0.283 square 0.283 square I cap. Okay, so these are our two I caps. The next two j caps we have, let's assemble the j caps together. We have minus 3 by under root 2 j cap. So we'll write this as minus 3 by under root 2 j cap. And we have plus 10 alpha j cap, plus 10 alpha. We'll write j cap outside, okay? This is 10 alpha j cap. We'll rub this j cap here, okay? So the answer will be like, now balancing the I components, as we balance the I components, we have, as we balance the I components, first take, we have AB by under root 2. AB by under root 2 is equal to 3 by under root 2 minus 10 into 0.283 square. So from this formula, we can get the value of AB. Okay, as let me perform this calculation to get the value of AB. Let me do it. So as far as the value of AB is concerned, the value of AB is, so we have 0.283 square, 0.283 square. That's equal to 0.08. So we have to multiply it by 10. We are multiplied by 10. So this is equal 3 by under root 2. This term is equal to 0.8. So this term is equal to 0.8. So we have 3 by under root 2. We have 3 divided by under root 2. That is 2.1 minus 0.8 multiplied by under root 2. That comes out equal to 1.86. Okay. So as far as the acceleration of B is concerned, the value of, from this equation, the value of acceleration of B comes out equal to 1.86 meter per second square. This is the value of acceleration of B, okay, from this formula. Now we will balance the J components. Once we balance the J components, we have acceleration of B by under root 2, acceleration of B. Now we have to balance the J components. We know acceleration of B is 1.86, okay? So we'll write 1.86 divided by under root 2 is equal to, that is we are taking this now, this is acceleration of B divided by under root 2 is equal to minus 3 by under root 2 plus 10 times alpha. From this formula we'll get the value of alpha, that is, let me perform it. So we have 1.86 divided by under root 2, that's equal to 1.315. So this is 1.315 plus this 3 by under root 2, that is 3 divided by under root 2, that is 2.12, 2.22 is equal to 10 alpha. Alpha comes out equal to, so we have 2.122 plus 1.315, that is 3.47 divided by 10, that is 0.344. So alpha comes out equal to 0.344. Since this is angular acceleration, its units are radian per second square. So this is the value of angular acceleration that we had to find. Okay, so this is how these questions are to be found. First, the velocity, angular velocity, and the angular acceleration formula. We'll find the value of angular acceleration. So we have to, in this problem, while you are using this acceleration formula, in the acceleration formula, we are coming up with a term of angular velocity. So first you will, in order to find the angular velocity, you will use the velocity equation. Okay, substitute the value of omega obtained from the velocity equation in the acceleration equation, obtain the value of alpha. This is how these problems are to be solved. Let's solve one more problem of acceleration analysis. Let me take this problem. The problem says the disk rolls without slipping. As far as the term is concerned, the disk rolls without slipping. This is a mistake. Okay, this mistake you will find in most of the textbooks, which write that the disk rolls without slipping. When you say rolls, rolling is always without slipping. I will explain both what we mean by rolling and what we mean by slipping. Okay, so you should always say the disk rolls. Don't write this without slipping. Okay, because when the disk is rolling, it does not slip. Okay. Okay, anyways, so the question is the disk rolls and has an angular motion as shown in figure. We have a disk and this disk is rotating. The sense of rotation of this disk is anti-clockwise. It's rotating anti-clockwise. Okay, its angular velocity is 6 radian per second and its angular acceleration is 4 radian per second square. Okay, the angular velocity of this disk is 6 radian per second and its angular acceleration is 4 radian per second square. Okay, if we are asked what is the sense, see, if we write the angular velocity vector omega, you will write this vector in terms of its magnitude. Its magnitude is 6, and if you have to write its direction, you curl your fingers, put your fingers in the direction of this arrow. Okay, then your thumb will be outside like this. Okay, if this is your x-axis, if this is your y-axis, then this becomes your z-axis. So you have to write this as this is 6k cap. Same is the case with angular acceleration. Angular acceleration alpha can be written as its magnitude. Its magnitude is 4 radian per second square. Again, you curl your fingers in this direction, it will be 4k cap. Okay. So now we are given. What we are given is that the disk its radius is 0.5 feet, and it's rolling in the sense of anti-clockwise motion. We have to find the acceleration of point A. We have to find the acceleration of point A at this instant. This is a very fascinating problem because here you will get a very, very important additional information, and a concept will build up in you when we are talking about the rolling of a disk. Okay, so the question is about, we have a disk, the disk is rolling, and this rolling disk is in such a way, it's rolling, its angular velocity is 6 radian per second, and its angular acceleration is 4 radian per second square. What is the acceleration of point A? This is the question that we have in hand. Before I solve this question, since this will take me a little bit of time, let's join the next class to solve this question. Kindly join the next class, the next lecture, to find the solution of this class, to find the solution of this problem. Thank you very much.